Steel poles are now being used by more than 600 utilities across North America at rural cooperative, investor-owned, and municipality utility organizations. Why are more utilities choosing to use steel poles? Steel poles are an engineered product. They are designed to ASCE and NESC standards. Their fabrication and quality meets or exceeds AWS and ASTM standards. Because they are engineered in a controlled manufacturing environment, each steel pole is uniformly consistent in quality and strength, offering a lower performance variation compared to wood. Pole dimensions are consistently the same from pole to pole, which simplifies hardware selection. On the aesthetic side, a variety of finishes are available for steel poles. These include galvanized, dulled and darkened galvanizing, weathering steel, and paint over galvanized powder coat. Advanced coatings, including polyurethanes for below-ground protection to direct embedded poles, further extend the life of steel poles. These coatings can be applied over the top of galvanized and weathering steel for a non-leaching, environmentally responsible corrosion barrier. Steel poles do have some important differences with their wood counterparts. Steel poles are hollow, making them much lighter than wood poles. The average 45 Class 3 steel distribution pole weighs approximately 600 pounds, which makes it at least 50 to 55% lighter than a wood pole. The steel pole's light weight makes it less expensive to ship and easier to handle at the job site. Steel poles come in a wide range of sizes and strengths. A single shaft section can run from 25 to 55 feet long. These sections can be connected for a variety of field situations. This also allows for easier storage and more economical shipments. Steel poles offer a reduced risk of catastrophic system failure or the cascading effect from a single downed pole. Steel is also widely used in remote locations where access is difficult and in areas prone to extreme weather conditions such as high winds, ice storms, fire, or excessive woodpecker populations and other pests. Steel poles are car strike safe. While wood poles may shear and fall down, steel poles typically yield and deform, keeping energized lines upright and away from the vehicle and the public domain. Wood poles can expand and shrink considerably with varying temperature and moisture. Steel poles are made of a material that does not decay and are not as affected by changing climate. Steel poles have a much more dependable and consistent strength rating throughout their service lives. Steel poles come from the factory pre-drilled, ensuring less crew time to prepare the poles for framing and equipment installations. With steel poles, the need to install the full-length copper ground wire typically required for wood is eliminated. Grounding provisions are provided along the length of the shaft. This reduces material theft, installation time, and required maintenance over the pole's service life. Steel poles pose minimal risk to birds when the same protections are utilized as with wood pole construction. Guidelines by the Avian Power Line Interaction Committee exist for cover-up materials and line clearance practices. Steel poles are non-toxic. They require no preservation treatments or retreatments over time as with wood poles. They pose no disposal issues. Steel poles can be repurposed within their service lives. They are recyclable at the end of their long service lives. Steel utility poles offer increased reliability, lower installed costs, and less maintenance requirements over the course of their service lives. Steel poles are the choice for today. This video covers the basic safety procedures for working with steel utility poles. Always follow all safety procedures and wear the appropriate safety gear for the job at hand. Working safely around or setting a steel pole is essentially the same as working with a wood pole. This video covers safety tips for non-energized work with steel utility poles. There are two sides to work site safety: public safety and worker safety. Both are equally important. Protecting the public is at the core of the utility line worker's job. Follow all company procedures and take into account these steps when on the work site. Always use warning signs, safety cones, and flagmen if necessary, as dictated by your utility. A job briefing is an OSHA requirement. The job briefing, led by the crew leader, should always cover hazard awareness, work procedures, any special precautions that need to be taken, and the location of energy source controls at the work site. Protecting yourself is your #1 priority. Utility work is demanding, and being fully aware of your environment is critical. Wearing the required personal protection equipment is mandatory. The personal protection equipment, or PPE, required for non-energized work includes safety glasses, hard hat, safety vest, steel-toe boots, leather work gloves, and long-sleeve shirts to protect against UV exposure. A visual inspection of all tools and equipment is also important to maintaining a safe work site. This includes slings and a pre-trip inspection of the digger derrick truck. This video covers the field deployment of steel utility poles. Steel poles are hauled to the installation site just like wood poles. When loading at the factory, the poles are usually cribbed to maintain separation between the pieces in order to protect them from damage. A steel pole's lighter weight means that more poles can be hauled in a single load. Typical load sizes range from 50 to 80 poles for lesser class poles and 20 to 50 poles for greater class poles. Pole height and shaft count affect load sizes. Typically, poles that are 55 feet and taller are loaded as 2 sections and later joined at the work site. A steel pole is less than half the weight of a wood pole. This makes steel poles easier to handle in the field, and when necessary, steel distribution poles can actually be carried on the shoulders of strong linemen. The weight chart shows that a 45 Class II Southern Yellow Pine weighs 1,705 pounds, and the same size pole in a Douglas Fir weighs 1,426 pounds. The steel pole that is equivalent to Grade B construction weighs 700 pounds. When hauling steel utility poles to a job site on a flatbed trailer, slight modifications to the trailer are necessary. When loading, install rubber material where the poles contact the trailer to eliminate steel-on-steel contact. The rubber material also protects the below-ground coating on the poles, which guards against corrosion. Avoid using chains to secure steel poles to the trailer. Use nylon strap tie-downs instead. When loading steel poles, attach a 2-inch nylon sling to the digger or derrick winch line. Slings with rubber coating are recommended because they are less prone to slippage. Do not drag the steel poles across concrete or asphalt, which can damage the protective below-ground urethane coating. This video covers drilling of steel utility poles. Steel poles offer 2 options for drilled holes. They can be drilled at the factory, or they can be drilled in the field. Most poles come pre-drilled from the factory and are tailored to utilities specification standards. Pre-drilling does not in any way compromise the integrity of the pole. Holes in steel poles are also easily and quickly drilled in the field. Holes are typically drilled with a titanium stepped bit or a Christmas tree bit, using a battery-powered or electric drill. Magnetic drills with hole saws work well on thin and thick steel. When using a magnetic drill, an accessory is required to drill round holes. This provides a transition from the flat to round and ensures that the drill machine is secured to the pole surface. Holes can usually be drilled in 30 seconds or less. Using a lower drill speed and pressure feed provide a better quality hole and help extend the performance of the drill cutter. Because steel poles are hollow, 2 holes need to be drilled 180 degrees apart for each through bolt. Each hole is drilled individually. Use biodegradable, non-oil-based lubrication while drilling, such as soapy water, to cool both the pole material and drill cutter bit. These are the steps to take for drilling. Step number 1. Measure where the hole needs to be and line it up with any existing holes. Step 2. Drill the first hole. Step number 3. Use the string method to determine where the pole should be drilled on the opposite side of the hole. To utilize the string method, follow these steps. Measure the entire circumference of the pole with a piece of string. Fold the string in half and use that length to measure from the center of the first hole you drilled to the point where the second hole should be drilled. Make your mark and drill the hole. This video covers the framing of steel utility poles. Framing steel poles is similar in many ways to framing a wood pole. However, there are some important differences between steel and wood poles. Steel poles are hollow. This is why they are much lighter and easier to handle than wood poles, making framing on the ground for steel poles an easier process. Steel poles are a manufactured product. They have consistent dimensions from pole to pole, so the hardware needed for framing can be predetermined. Bolt selection is simplified. The same lengths are used for every installation or framing. Wood poles can because they are made of a material that does not decay with varying temperature and are not as affected by changing climate. Steel poles are made of a material that does not decay and are not as affected by changing climate. Steel poles have a much more dependable and consistent strength rating throughout their service lives. And because of their durability, a line worker has fewer concerns about damage from insects or woodpeckers. Hardware on a steel pole doesn't need to be torqued as tightly as on wood poles. You can use a torque wrench or tighten hardware to snug tight. For the most part, you can use the same hardware for both steel poles and wood poles. Curved or square washers are acceptable and determined by the steel pole shape. Wood or fiberglass crossarms and dead ends. Welded attachments can be installed during the manufacturing process for unique applications. Pole banding can be used for attachments such as meter loops. 1/4 by 1 inch self-tapping screws can be used for attachments such as installing pipe straps. However, there are some exceptions on steel pole hardware. Hardware with cleats, such as some guy attachments and grid gains, shouldn't be used on steel poles. Lags are replaced with 1/2 inch machine bolts. With steel poles, there's no need to run a ground wire up the pole because the pole serves as the ground. Threaded inserts, called rivnuts, can be placed anywhere on the pole where bonding attachments need to be made. Fiberglass pole top pins and extended conductor clearances may need to be used to achieve the required basic insulation level, or BIL. This video covers the installation of steel utility poles. Installing a steel utility pole is the same as installing a wood pole, with a few minor differences. Direct embedment is the most common foundation type for steel utility poles. This includes both distribution and smaller transmission poles. Hole depths are typically the same for steel poles as for wood poles and are decided by the line designer. However, because a steel pole is an engineered product, pole diameters are consistently the same, while wood pole diameters often vary by several inches from pole to pole. Consistent steel pole diameters mean that the digging auger can be sized to the poles being set, rather than requiring a larger than needed auger on site to accommodate different diameter wood poles. This also minimizes the amount of backfill material needed at each site. Backfill material is typically native soil excavated from the hole, or an engineered backfill, such as gravel or crushed rock with drainage characteristics. Foam is also an option for backfill. When foaming poles, use excavated soil for the first foot of backfill to allow drainage. Whatever backfill is used, the pole placement is generally the same as for wood poles. Nylon straps are used to set steel poles rather than chains or steel rope slings. Double choke the nylon sling around the pole to avoid any slippage. A two-piece pole is joined while the pole is being set, or it may be joined as a separate operation prior to the pole lift and hole set. The lighter weight of a steel pole allows the truck setup to be positioned farther away if necessary. Canting the pole is accomplished with a nylon strap and a cant hook. The backfill material is placed in the hole and compacted by tamping to improve the pole's stability and resistance to leaning. Good tamping procedures should be used. Also, take care to avoid damaging the protective barrier coatings on the pole to ensure proper corrosion mitigation over time. Steel pole removal can be accomplished with a hydraulic pole puller. The steel pole that's pulled can often be reused in another location. This video covers the joining of two steel utility poles. Two-piece poles are needed for line designs that require additional height clearances, such as road crossings or multiple circuits on a pole. Poles under 55 feet in length are commonly furnished as single-piece poles. However, shorter poles can be fabricated into multiple sections. Taller poles are sometimes fabricated and shipped as multi-section poles. This saves on shipping costs and can sometimes be an advantage in moving poles to hard-to-access sites. The most common joint type for mating the pole sections is a slip joint. This is a friction fit connection that is simply made in the field. However, for the joint to work properly, there must be good contact between the mating sections, and a minimum overlap length must be obtained using an axial force per the manufacturer's recommendations. The overlap lengths are specified by the pole manufacturer and typically found on the product drawings. It is best to assemble the pole sections on the ground and erect the pole as a unit. The sections should be aligned on the ground and supported, typically with wood blocks, to readily fit together. Proper alignment of the pole sections is made at the location of the weld seam or per the manufacturer's instructions, which may be ID tags or a pre-existing framing pattern on the pole design. Take care to prevent dirt, stones, and other debris from getting trapped between the mating surfaces. Mating surfaces can be lubricated for easier assembly. Soapy water is an excellent lubricant. Do not use a lubricant that will later leak from the joint and stain the pole. There are several methods for applying the necessary force to achieve a tight joint. The method that is selected may depend upon the size of the pole sections, the pole design, and available equipment. The two most common methods are: number 1, the use of 2 or more ratchet chain hoists or similar devices on opposing sides of the pole sections. These may pull on cables secured to the pole sections with a choke-type hitch or attached to bolts installed in appropriate through holes. Equal forces should be applied by the hoist simultaneously. If bolts are used, the forces must be applied to no more than 1.5 inches from the surface of the pole section. For larger transmission poles, a hydraulic jack is often used, which requires welded nuts attached to the pole sections. The joining procedure is similar to the hoist procedure, but provides more compressive force. When the forces are applied as a slow, steady pull, tighten the joint by oscillating the advancing section with the supporting crane, or strike the pole in the joint area with a hammer using a cushioning block of wood. Apply forces until the joint is tight with no more than small gaps, which are sometimes caused by a slight mismatch in the shapes of the mating sections. Make a final check to ensure that the specified minimum overlap has been achieved. An overlap between the minimum and maximum or nominal splice is considered an acceptable joint if force has been applied and no additional movement of the joint results from an increase in applied force. Poles used in H-frames and other multi-pole structures will sometimes use flange joints instead of slip joints. Flange joints allow for tight tolerances to be maintained on overall pole lengths. They also have a higher axial load capacity than slip joints. This video covers the climbing of steel utility poles. The basic equipment that a line technician needs for a steel pole is identical to that used for a wood pole in a non-energized environment. Company-approved safety glasses, a non-conductive hard hat, leather work gloves, a standard body belt and safety strap, or appropriate fall protection, and hard-toe climbing boots with good arch support. As with wood poles, climbing procedures vary from utility to utility. You should always familiarize yourself with all company safety practices before attempting to climb a wood or steel pole. In our training instruction, the line worker will be belt secured to the structure at all times of elevated work activity. The most common climbing systems involve the use of removable steps. Almost all manufacturers offer one or more styles of this type of step, but they all generally work in the same fashion. The step system mounts to a single open hole drilled in the wall of the pole at the desired elevations and circumference positions on the pole. Most utilities design both a climbing pattern and working pattern on the pole. Climbing positions are alternated on opposing sides to ascend and descend the pole. Work positions are multiple step provisions grouped at a specific elevation on the pole to provide mobility to the line worker while at an elevated work position. This video includes a basic overview of various climbing steps, including the Hubbell Chance step, the Senior step, and the Valmont Newmark step. Each step is specifically designed for steel poles. This is the Hubbell Chance step system. The system has 4 components which are attached to the wall of a steel pole: rivnut threaded insert, faceplate, mounting bolt, and a removable slip-on footstep. A series of installation instructions follow. Drill a hole in the pole shaft per manufacturer's size requirement of 13/32 of an inch. Install the rivnut in the open hole. Place the faceplate toward the pole wall align to the riv nut, and install the mount bolt through the faceplate to the riv nut threaded insert. Be sure to align the faceplate with the step tab down, as the tab supports the bottom of the step opening. With a wrench, tighten the vertical position. Install the step to assure proper fit with the step opening, completely covering the bolt head. Adjust the bolt and faceplate as needed. This is the Senior Step System. This system has 4 components which are pre-assembled by the step manufacturer: the foot step bolt, faceplate, star washer, and locking bolt. This step has an assembled feature which prevents the 4 components from being separated when loosened. A series of installation instructions follow. Drill a hole in the pole shaft per manufacturer's size requirement of 13/16 of an inch. Loosen the lock nut completely off the threaded portion of the step assembly, allowing the nut, washer, and faceplates to move freely to the smooth end of the step bolt. Position the square, bent end of the step bolt into the open hole, and position the step bolt to the level position. Holding the step bolt back and against the interior wall of the pole, align the faceplate to the exterior wall of the pole with the top marking up. Slide the washer and nut onto the threaded surface. With a wrench, tighten the locking nut to a snug fit. Confirm the faceplate and step assembly are firm to the wall of the pole without any gaps or loose motion. This is the Valmont Newmark step system. This system has 4 components which are pre-assembled by the step manufacturer: the cast step peg, step bolt, and 2 locking nuts. A series of installation instructions follow. Drill the hole in the pole shaft per manufacturer's size requirement of 1 1/8 inches. Do not remove the lock nuts from the threaded bolt. Loosen the lock nuts completely to the end of the threaded portion of the step bolt assembly, allowing the cast foot step movement to the end of the threaded step bolt. Position the round bent end of the step bolt and round end of the cast step into the open hole, and position the step bolt to the level position. Holding the step bolt back and against the interior wall of the pole, align the step cast flat portion to the exterior wall of the pole. Spin the inner nut across the threaded surface. With a wrench, tighten the nut to a snug fit. Confirm the cast step assembly is level and firm to the wall of the pole. Slight gaps exist when mounted to a round pole. Spin the outer nut into its locked position. In most cases, the climber should be able to install and remove the Hubbell Chance temporary steps by hand, but in some cases, a hammer may need to be used to tap the step in order to detach it from the steel pole. When climbing a pole with slip-on removable steps like the Hubbell Chance type, care should be taken to not loosen them as you climb. The Hubbell Chance, Senior, and Valmont type steps built onto the pole may be considered either temporary or permanent. This is a decision made by the utility. Most utilities prefer to use a temporary step type practice for climbing provisions lower on a pole near the ground line in order to protect the poles from unauthorized climbing. The fall restraint system shown in this video is the Buckingham Super Squeeze with a rope auxiliary safety strap. Several other suppliers of climbing equipment offer similar fall restraint systems. Each supplier should be consulted about the equipment and its use for climbing steel poles.
My name is Tim Batty, Western Region Sales Manager for Buckingham Manufacturing. The utility industry has always had a commitment to safety, and as advances in technology come, so do the advances into safety equipment, particularly fall protection. Today, I'm going to show you how to use the existing fall protection equipment that you would have on wood poles, the Super Squeeze, and retrofit it to be used on the steel pole. Now I will put on my lineman's belt and my secondary lanyard. Your secondary lanyard, the buck adjuster, which is already attached, and your super squeeze. The only difference between your super squeeze on wood poles and the steel pole is these two attachments that cover the teeth on either side. Besides these two attachments, you would use the exact same equipment that you would use on a wood pole on a steel pole.
Preparing to climb a steel pole is no different than a wood pole. Climbing equipment should be inspected for defects, and if any are found, the equipment should be replaced or repaired before ascending. The area around the pole should be free of equipment and debris. The line technician should visually inspect the pole and choose the climbing route that appears to be the safest. Always inspect the pole before starting your climb. Keep these safety tips in mind when ascending or descending a steel or wood utility pole. One of the most common concerns about working on steel poles is the challenge of trying to work at an elevation from a single position. To work around this problem, a simple work platform can be used. The work platform is easily installed at almost any location along the pole, providing the line worker freedom to move about the pole and work area. A platform option would be used in conjunction with the previously mentioned step attachments. The step attachments would be used to ascend and descend the pole.